critical points are points on a function where the derivative equals 0 or is undefined. Why does this matter? Because the derivative tells us the instantaneous rate of change, like how fast a function is increasing or decreasing. When the derivative is 0, the tangent line is flat. That means the function isn't changing direction at that instant. This is important because all maxima and minima happen at critical points. So a critical point may mean that there is a maximum or minimum. Take a look at this example. Say we have this function f of x. Where are all the critical points on this function? Well, critical points are where the derivative equals 0 or is undefined. So what is the derivative of f of x? Since we are adding and subtracting, we can take the derivatives separately and use the power rule. To find the derivative of x to the power of 4 over 4, we can take out the 1 over 4 as a constant. Now, using the power rule for x to the power of 4, we can move down the exponent and then decrease it by 1. 1/4 times 4 equals 1, so that gives us x to the power of 3. And similarly, for x to the power of 3 over 3, we can take out the 1/3, and the derivative of x to the power of 3 is 3 times x squared. 1/3 times 3 makes 1, so we're left with x squared. The derivative of 3x squared is just 6x, and the derivative of a constant is 0. So our simplified derivative is x to the power of 3 minus x squared minus 6x. Now we can factor this, which gives us x times x minus 3 times x plus 2, and this is the derivative. Whenever this expression equals 0, we have a critical point. Now because we factored, it's very easy to find when this expression equals 0. If any of these terms equals 0, the entire thing will equal 0. So that means the derivative is 0 when x equals 0, 3, or negative 2. These are our critical points. And taking a look at the graph of f of x, we can confirm this. At negative 2, 0, and 3, the derivative of f of x is equal to 0, as the tangent line is horizontal. Cool. Now check out this graph. Can you find all the critical points? Well, when x equals 1, we have a maximum, so that's definitely a critical point. When x equals 4, we have a critical point because we have a minimum. Now, remember that as long as the derivative for a point equals 0 or is undefined, we call that point a critical point. There is another critical point on this graph. That's when x equals 3. Here, although we don't have a minimum or maximum, there's no tangent line because the derivative is undefined. So 3 is another critical point. As you can see, as long as the derivative equals 0 or it's undefined, we have a critical point. Once we find critical points, we can then look for minimum and maximum points, but we'll look at that in another video. For now, it's critical that you hit that like button, subscribe to the channel, and share this with friends. Yeah, I know, that was kind of cringy. Anyway, keep working hard and keep learning. Thank you for watching.